Welcome to part 5, in our new game development series, focused on the 3D FLAX game engine, and second entry in the Wolfenstein 3D game tutorial. In this video, we are going to integrate the gun pistol and its firing animation, and we will start to detect the fire hit, as to integrate in the next episode, the enemies. For this, we will go in depth into Flax Engine UI system, and implement our own version of a sprite renderer, as to be able to display and animate our different guns. So, let's jump in. The first thing that we need to do is to create a new UI canvas. This is the top root actor for any user interface. All other elements will be defined as children of it. It is where you can set up the UI to be camera space, screen space, or world space. The last one being in case you want the UI to be integrated in 3D in the world. To create it, from the toolbox select the GUI tab, and drag the UI canvas into the scene view. A new actor will be created in the hierarchy. You can rename it if you want. We will keep for now the default name. The UI canvas by itself don't do anything. If you want to display an UI object, then you need to add the next element in the GUI functions, the UI control. From the toolbox, drag the UI control element into the UI canvas actor in the game hierarchy. Rename it to gun, as we are going to use it to hold our gun sprites. Let's import the gun sprites. In the description to this video, you will find a link to the sprites that we are using, based on the sprite sheets from the previous class. So, from the folder where you have downloaded the sprites, drag the pistol sprite sheet into the content browser. This will pop the importer interface. We are dealing now with transparent sprite sheets, which will require the type field to be set to color RGBA. Since we have several sprites in the image, check the As Atlas, Never Stream and Compress checkboxes. In the max size, choose the option 512 pixels. Click the Import button. This will import the file into the content browser in the right format, but we have not yet defined the different sprites to be imported. Let's do this now. Double-click on the image imported. It will open again the import function, but this time we can see that we have more options. Especially in the menu bar, where we can find a button named Add New Sprite. And, above the configuration, set in the previous step, we can now see a tab called Sprites with an element named Default. This the default sprite atlas without any configuration. So, if we were to use this, we would get all the sprites drawn into the screen. We don't want that. We want just one sprite at a time. Click on the default sprite. In the size field, type 64, as it is the measure in pixels of each of our sprites. Rename it to Pistol 1. This configuration we'll get from the sprite sheet, the first sprite located at position 0, and we'll name it Pistol 1. Click now the Add New Sprite. Click in the new default option. Change again the size to be 64, and now, in the field location, since we want to get the second sprite, we need to add 64 to the previous location, which was 0, which will result into 64. Repeat the same process for each of the 5 sprites in the sprite sheet, with locations increasing each time by 64, so 128, 192 and 256. Click Save from time to time to avoid losing the configuration and applying the changes. OK. We have now correctly configured the system to use 5 sprites from the image that we have imported. Now, to show them, we need to configure the UI control element, that we have renamed as gun, to show the sprites. Click on it. In the inspector, click on the button Set Type. And choose the option Image. This will tell Flax we want the UI control to be displaying an image when active. We can see that new options are unfold associated with the type change that we have just done. They are basically responsible for controlling the overall appearance of the UI control, and where it has to be displayed in the screen. We will get to it later, but for now, we want to configure the sprite. So, click the option named Brush. And in the drop-down field named Type, choose the Sprite option. This will create a new entry called Sprite. If we click on it, we can see now an empty slot, where to place our imported sprites. Drag into it, from the content browser, the gun sprites that we have just finished importing. As soon as we do it, the UI control displays the first sprite in our sprite sheet. By default, it is located in the left top corner, but we can fine-tune it by changing the values of the scale and the location. Play around with the values to get something that fits your situation. Let's run the game. And, we can see that we have our gun right where it should be following our point of view. That is nice, but we need also to animate it as to show that we firing. By default, Flax Engine doesn't have specific tools to animate sprites. This means that we need to develop our own custom class to display and animate the game sprites. The class that we are going to develop now, will be used for the guns, and for all the enemies and props, that we will have to use in the game later, as we integrate more elements. So, let's jump in creating our own sprite renderer. Animations are the result of flipping images at more than 24 images per second. So, if we want to create the illusion with the UI control set to image, we need to change the element that is used to paint on the screen on each frame to a new image. In Flax, and more specifically in images, the property that holds what is being painted on the screen, is the brush. But it holds the entire sprite sheet, so if tried to paint it without sprites we would get the entire set of sprites. We can convert the image brush into a sprite brush, which holds an index that allows accessing independently every frame on the sprite sheet. This means that if we can get to that data, we would be able to create our animation function. Let's start. First, let's add the UI system by adding to the top of the file using Flax Engine GUI. Now, let's define a public UI control variable named control. A private image_image. A private sprite brush sprite, that will hold our sprites. A private sprite handle SPR, that will hold the control information about our defined sprites. A public int frame that will hold the current sprite to be painted. A list of sprite brushes that we will use to hold a direct reference to the sprite that we want to paint on each frame. A sprite.list variable that will allow us to know how many sprites we have in the image. and we will save in the next integer variable SPR atlas size. The first thing that we need to do is to reset the frame to 0 when starting. So, in the function onEnable, let's initialize the frame to 0. Then, and on start, let's grab a reference to the image structure within the UI control element, by using the get function associated with the type image, on the control variable that we have received through the inspector. From the image, let's grab the reference to the sprites, by assigning the image brush to the sprite brush variable sprite. Since they are not the same, we need to cast the types. Since we have now the sprites, we can get the sprite handle reference that allows us to control and access the different sprites. The first thing to do with it is to get the number of sprites that are kept in the sprite sheet. This reference is held on the sprite atlas propriety of the sprite handle. Through it, we can then access the number of sprites by accessing the length of the atlas. With this last data, we have all the information that we need to initialize our animation structure. First, let's initialize the image brush to a new sprite brush instance of the first sprite. Then, for all the sprites in the atlas, let's save a reference in the list of sprite brushes that we have created. We can move between sprites by increasing the index of the sprite handle variable SPR. When finished, we will have in the list animation a sequence of all the sprites that were passed to the class. Now, if we want to animate, the only thing that we need to do is to increase the frame and assign to the image brush the new sprite. Let's create the function render frame that will do just that. We need to check if we have reached the number of sprites, to get back to 0. Later on, we will implement a looping condition and some other variables and functions to control the animation. Finally, in the on update, let's add render frame. Let's check if we have errors in the code. And yes, we have some. Let's delete the onEnable method because we already had one. Let's fix also a couple of typos. We are still not used to the caps letters. Let's do also a quick modification to render frame. The way it is implemented will create problems. So let's put the testing of frame being greater than the number of sprites before we actually render it, and then let's directly increment the frame as we use it in the function. Done. Now, let's add the sprite renderer to the UI control gun. And let's associate it in the inspector. Let's run the game. And as soon as we run it, we can see that the gun is animated with the fire animation. It won't stop as we have not implemented any control, but it shows that the animation system is working. Let's implement now some basic systems to control better the animation. For example, in a fire animation, we usually don't want loops, we want the fire animation to be played when we press the fire button. So, go back to the sprite renderer function, and let's add a couple of new variables. A public boolean looping will tell the class if the animation is to be looped or not. A public boolean has finished, which will allow an external function to know if the animation has currently finished being played. Let's go back to render frame and let's add these variables into the animation control. So, the first thing is that the animation is reset back to 0 if the animation is set to be looping. If not, then if not looping, the animation has finished playing and should not be rendered to the screen. Finally, if we want to control the animation, we will need at least a control to play it. Let's create a play function, that will be resetting the has finished to false and the frame to 0. But of course, then, in the render frame, the animation will have finished if we have played all the animation and there, so the frame counter is bigger than the number of sprites to be played. So, the basic building block is ready. But we need now to take the control of the animation from the player, as to only run the animation when firing. For this, let's open the player Fps script. We will need different variables to hold each different gun and state. The way we are setting it up is that we will have for each gun 2 UI control elements, one for firing and one for idling. When we want to change states, we only need to disable the corresponding UI control variable. In this case for the pistol, a pistol idle and pistol fire. Then, we will need a reference to the Sprite Renderer class, to run the animations. Let's go to the onStart method, and get the reference to the Sprite Renderer on the UI control. In this case, from the pistol firing, which will be the one with animations. To shoot, let's go to the onUpdate method, and under the input action fire, let's add a new function named shoot where we will concentrate the shooting instructions. In the shoot function, let's disable the fire idle UI control, and let's activate the pistol fire one. If we are not firing, then let's create a new function not shooting. Where we will reset to their original state the UI control variables. For this function to be run, we need to be sure that the fire animation has finished, because if not, as soon as we would stop pressing the fire button, the system would cut the firing animation. This means that in the shoot function we should also start playing the animation. Let's go back to the scene view. Let's duplicate the gun UI control and let's name one gun idle, and the other on gun fire. Let's disable in the gun idle the Sprite Renderer script as we don't need it to be animated for now. Let's drag the references to the player script. Let's run the game and let's try to fire the gun. Yes. We can certainly fire. Let's now try to detect fire hits that will allow us later on to damage enemies. So in the shoot function, we will be throwing a raycast that will try to hit enemies in front of our gun. So, we need raycast hit variable named hit to hold the values. And then, actually, send the raycast by using the physics raycast method. Before populating the method, we will need a point from where to fire the ray. So, let's go to the scene view, and under the player actor, let's create an empty actor that we will be calling fire point. Let's move it slightly on the z-axis forward to be out of the collider for the player. Let's go back to the player script. In the raycast method, for the origin of the ray, let's use the point that we have created. We have not yet defined the variable that will hold it, but we will name it fire point. We will fire in the direction where the player is looking at and will receive the results of the collision in the variable. If we have hit anything, then let's draw a small wire sphere in the hit point to depict it. Let's go up to the top of the class. And let's define a public actor fire point. Let's go to scene view and let's drag the fire point into its slot on the player script. But it seems that we have again another typo. Yes. The raycast position should have a capital letter. Let's check the execution of the code. Okay, we can see that the camera is the object that is rotation and not the player rigid body. This means that FirePoint should be a child of the camera as to rotate with it, and always throw the ray cast in the right direction and not the actor. So, in the player script, let's replace the actor direction with the FirePoint direction. Let's try it. Okay. No. Although the FirePoint moves with the rotation, its direction is not changing, because we are rotating the camera. So, let's go back to the player script again, and let's replace the FirePoint with the camera direction. Let's run. And yes, we can see that when we fire the gun, where the raycast hits colliders, we have a sphere popping showing that the collision has been correctly generated and addressed. In the next episode, we will create the enemy's sprites and behaviors to start bringing the game to life. Thanks for watching up to the end of this video, and we hope that you have liked it. If it has been the case, then don't forget to like the video. It is a good way to support our work and to make more people find us. Don't forget to subscribe and to click on the notification button, to be alerted for new weekly videos. If you have any requests on where you want the tutorial to go, any questions, problems, or comments, don't hesitate in putting a comment and we will answer as fast as we could. See you in the next video, game developers.